if other students will also help. Uh, this is your 10th semester, my student, and from the 11th semester, your final year project will be, on the card. And on that note, you need to make groups. Already, Hafiz informed me about that, and I told him that you start the group making process. How many groups, Hafiz?
Three, sir, three.
Three groups. So four, four, three probably.
443. But sir, there is a problem.
What?
Two of our students they said we will not we will make only two-person group as a group.
No.
I said it's not possible. They said we will make, because major of the students they need electrical sector, and that two-person they need telecommunication. So they said we will make a group. We can do what other three-person or four-person can do. You understood, sir?
No. Two is not possible. You have to make 443. Okay, because two, on that case, more teachers will be, and the department will not allow that. Okay, department will allow 443. Two is very less number, and before going that, make that 443. No problem. But the main thing is that after finishing uh, your main thing.
Ashik bhai, mute yourself, bro.
Yes, I'm muted. So after finishing your group, then you need to now almost 7 students have joined. So after completing your group, then you need to do the formalities. The formalities means you make the registration for the project, and the project registration is for 2 semester. It is there is an amount that is 2,500, something like that. But please confirm by calling the program officer. And there is a process of sending that registration fee using Bikash. So Ashik will take this responsibility for all, and will contact the program officer that how to pay and how to complete this process. The payment, then the registration process, he will give a form. But as we are in the not, the campus is not on, so that's why you can make soft copy of the form. I'm providing in your group, messenger group, just the format of the soft copy. Every group will do like that. Just giving one format. Can you see, my student? Yes, in the messenger group you can see. You can take the format. One of the students in the evening batch, they need to make 5 or 6 students per group. Okay, for in the day batch it is 3 to 4. So the 2 students is not possible. That you see that some informations are given: your name, your project, basically your group, your names, your role, and your registration number. And if you have any picture, you can attach, no problem. Then some of the areas of the field. Areas of field are there, digital signal processing, electronic device, signal processing, power system, automation control, very large scale, that means VLSI, the mobile communication, the power electronics, wireless communication, and others, if any other sector. Then you have for each group, but you have to choose one subject, the main or probably the first topic you want to work, that you should keep on the number 1. Then the second priority will be second, and then the third priority will be the third. So that's why you have to choose 3. You don't need to choose the teacher name. Don't choose the teacher name. Choose the topic that you want to work. If you want to work in power system, then power system will be the first. If you want to work power electronics, it will be first, or mobile communication, it will be first. Okay, but you also need to give the alternates. So then when these files are ready, and also the registration, by providing the registration fee, after that I will forward the soft copy to the department chairman, and he will decide that which teacher he will assign for that particular group according to the choice of your subject. That is your choose in power electronic or electronic device, a power station, or something like that, automation and control. So according to that, the department chairman will choose that. So this is the process. So as soon as you do your registration, as soon as I will submit, and if not in this semester possible, probably by the starting of the next semester, you will get your supervisor. If everything is done within before that, okay. Just like day 24 has day 24 has already the supervisor they have. Day 25 has already got that recently. They have taken so much time that their supervisor got they like just last week. Okay, so there was some delay on that case. So if you want that, sir, we want our supervisor from the very beginning of the semester, you can finish that overall process, and you can also
We
take
will
help.
finish. We will finish this week. This coming weeks. We need to start as soon as possible.
Okay, but as the the course or the project starts from 11th semester.
Yeah, 11th
So
semester is near, sir.
yes, yeah, near, because after this month probably the exam, then the 11th semester probably this from
Yeah.
September. So you can have the all the process, and about the process, you can also tell your big brother from day 25 that how they have finished. They can also help, no problem. Okay, but there are
Okay.
two process. One is this form you have to fill up for. So three groups has three form. Am I clear? Three
Yeah.
groups has three form, and every group they need to mention that which three topic their priority three topics. So according to their priority topics, then the teacher will be assigned, and then the supervisor and you will sit together, and you will discuss and fix that which topic you are going to work, and which subject, and probably he will guide from there on. So that is my responsibility as a coordinator, that to inform you all the process. Are you clear about the process?
Yeah. Yes, sir.
The registration fee is 2,500, and you need to make this kind of soft copy. So I have already given you the template. You can make it, or because the university is not in the on campus. On campus, there is a hard form, so you can fill up at that time. But now, right now, you cannot as make it.
No
Uh,
problem. We can make, sir, this
you can
format.
make from this easily, isn't it? You
Yeah.
got the format. You can easily make the table and make three groups, and send me that groups easily. So you make three groups, select those topics. The topics are already available here. Digital signal processing, electronic device, signal processing, blah blah. So 8 or 9, 10 topics are available here. So you can just choose three, or you can choose your other topic also. That means others, you have to mention that. Okay, so according to that, the department chairman will assign. Okay, so one more thing, my students, don't write the teacher's name. That is not correct. Don't write any teacher's name, because every teachers are good. No, it's not a
Yeah,
big
sir.
deal.
No problem. We will not write, sir. No.
Every teacher will help you. So I think that now the project it is clear for all of you.
Yes, ma'am. Yes, sir.
Clear?
Yes.
Okay. What about the uh, I don't know that I have discussed or not, but let me tell one more time that university has already issued a formal notice about that if you have no due from the last semester, if you will get 20% waiver. Have I
Inshallah.
told?
Yes,
Have I
yes.
have I
Yes, sir.
told?
Yes, sir.
So in this point of view, probably Omar and Mahmoud,
Yes, sir.
these two students has no due till
Yes,
last
sir.
semester.
Yes, sir.
So if you pay before 15th July, you will get probably that 20% due, 20% waiver. What is the amount of a semester fee?
33, sir.
33, 20%, 33, it will be almost 6.5 thousand, something like that. It's a huge amount. Okay,
Yes, sir. Yes, sir.
so you can take this responsibility. And what about other students? Yasin, can you hear me? Yasin, Yasin,
يعني معك كنت أنا وسمين.
Yasin Ali, Ali.
Yes, sir.
So what about your semester fee?
Sir, this semester I'm going to submit 40,000, sir.
So pay before 15 July. That was the deadline probably.
15
Okay.
July.
Yes, 15 July. Yes. Okay. So any more question, my student?
No, sir.
My student? Any more question, Ashik? Ashik শুনতেছ? আশিক,
No, sir.
শুনতেছ?
Yes, sir. শুনতেছি।
তুমি ওই বাবু ভাইকে ফোন দিবা। বাবু ভাইকে ফোন দিয়ে বলবা যে স্যার আমরা এই যে এরকম এরকম প্রজেক্টটা আমরা আগে আগে শেষ করতে যাচ্ছি, তো কিভাবে আগাবো? ঠিক আছে, মামুন স্যার তো আমাদের এইভাবে বললো।
Yes,
তো
sir.
তুমি ওদের কাছ থেকে ওনার কাছে জেনে নিবা কিভাবে বিকাশে পেমেন্ট করা লাগে। বিকাশে আই এন লিখে তোমাদের রেজিস্ট্রেশন নাম্বার দেওয়া লেখা। এখন সোমালিয়ানরা ওরা কিভাবে করবে এটা একটু জেনে নিবা, বা 25 ব্যাচে তোমাদের ভাইয়েরা যারা করছে ওদের কাছে একটু জেনে নিবা যে ফরেন স্টুডেন্টরা কিভাবে পেমেন্ট করছে। ঠিক আছে, ওরা কি ব্যাংকে গিয়ে করছে কিনা একটু জেনে নিও, ওদের একটু জানাই দিবা। ঠিক আছে, ওকে okay, let me start our today's
sir.
topic. We have already discussed so many things. Let me start.
Yes, sir.
Okay, let me mute my students, and then if you have any problem or any questions, okay, now I think that the sound is clear. Okay, my students, today we will discuss a different chart that is very important, that is Mollier chart. From Mollier chart, how to cope up the value of different types of steam, finding out the different type of states of different steam. Okay, so before going there, one word is very important. What is entropy? We discussed probably in our earlier classes. The entropy is a kind of heat, but it is the here I have much more explanation, that is a thermodynamic quantity that representing the amount of energy in a system that is no longer available for doing mechanical work. Okay, it's a, entropy is a very critical word. It's a very critical word, but it is basically in mathematically it is represented as joule per Kelvin. In the SI unit, the universe international system of units, they represent joule per unit. We all know that joule is the unit of heat energy, or energy, any kind of energy. And per Kelvin, when we introduce per Kelvin, that means that in every Kelvin how much energy that is considered. That mathematical term is basically considered as entropy S. Okay, give me just 1 minute. I'm just coming. Just give me 1 minute, my student. 1 minute just. Okay, sorry for that moment of emergency. So what we're talking about that entropy is a heat component definitely, but it's a critical heat component. But we will not go so deeply uh, because uh, uh, because entropy is a very large extent amount of explanation. So, but in a single line, if we want to draw a line about entropy, it will be joule per Kelvin. Okay, the amount of heat. If I want to increase the temperature 1 Kelvin, that amount of heat that is necessary, that is entropy. Okay, and it's a thermodynamic quantity definitely. So let me clear. So today we'll see a particular chart that is basically known as Mollier chart or entropy enthalpy chart. Okay, entropy enthalpy chart. So that chart will help us to assess the situation of different steam, different types of steam. We all know that there are three types of steam. One is wet steam, another one is dry steam, and finally the superheated steam. There are three types of steam. So this Mollier, scientist Mollier has gathered this kind of information and made a chart. So that's why it is known as also entropy enthalpy chart and also popularly known as Mollier chart. Okay, so where the entropy is in the x-axis and enthalpy is in the y-axis. So the chart looks like this. The chart looks like this. In the x-axis, as you can see, in the x-axis, you have the entropy, that is S. We defined entropy as S, and in the y-axis, we have enthalpy, that is H. Okay, H and S. And there are some several points. We all know that for steam, or different types of steam, pressure is very important. Pressure line is very important. So in this Mollier chart, there are some pressure lines, that is vertical lines. You see that this type of lines are pressure lines. When you see this kind of vertical curved line, these are the pressure lines available here. And in the Mollier chart, there will be in middle, there will be a bold line, that is the dividing line. That line is known or popularly known as dry steam line. That line is popularly known as dry steam line. So above this dry steam line, all the lines are for superheated steam, and those lines are for temperature. And below this dry steam line, all the lines are for wet steam, and those lines are for dryness fraction. My students, those are two very interesting concepts, that for superheated steam, the main parameter or the main important factor is the temperature, that how much superheated steam, how much heated. So what is the temperature of the superheated steam? It is 300, it is 400, it is 500. And for wet steam, it is not about temperature, it is dryness fraction, that how much it is wet. That is dryness fraction. Suppose 0.8, 0.7, 0.6, it defines as the amount of dryness that is available. And in the dryness fraction, when it reaches 1, that means the steam becomes 100% dry, that is dry steam. So those are the informations that is available in the Mollier chart. So let's see the Mollier chart. So this is basically the main chart. As you can see from here, if you see properly, my student, that the main red line, the bold red line is basically known as dry steam line. Okay, the main red line is basically known as dry steam line. So this is the border. The dry steam is basically the border between wet steam and superheated steam. The dry steam is basically the border between wet steam and superheated steam. So above this line, the whole region is for superheated steam. and below this line the whole region is for wet steam. Okay, so we already told that for superheated steam the main important component is the temperature. The main important component is temperature. So for that, you see that you can see from here that these lines are temperature line. These green lines are temperature line. This is 250, this is 200, this is 150. You see that all these carved green line are temperature line. Okay, 400, 450, 500, 700, 750 up to 800. And below this dry steam line, I said that this region are for wet steam. And for wet steam, the main component or the main parameter is dryness fraction. So you see that these red line are dryness fraction. This line is for 0.95 dryness fraction. This line is for 0.9 dryness fraction. This line is for 0.85, 0.8, 0.75, 0.7, and up to 0.65. So what is dryness fraction? Suppose the dryness fraction value is 0.8. It means that among the water, 80% of the water has been converted to steam, had been converted to the dry steam. So 20% has been left. So we can also see in the x-axis there's an entropy 5, 5.5, 8, something like that. And in the y-axis, you can see the value of enthalpy. Okay, then the y-axis, 2000, 2500, 3000, 3500, something like that. And these green vertical line are pressure line, my student. This green vertical line, not vertical, exact vertical, but this curved vertical line. This green one, this is 0.5 pressure, this is 0.2 bar, this is 0.1 bar, and up to 500 bar. So these vertical line are pressure line. So this is all about the Mollier chart. So let's see that how we will use this chart to find out some of the important information. So my student, first problem, suppose it is shown that, or is told that using Mollier chart, find the enthalpy drop. Drop means how much enthalpy has been less, drop means reduced, or how much it has been less. And the final condition of the steam, when it is expanded isentropically from an initial pressure of 30 bar and 350 degrees Celsius to a pressure of 1 bar. So basically there are two situations told, that you need to find out the enthalpy drop and also the final condition of the steam when the steam at first the pressure was 30 bar and the temperature was 350 degrees Celsius to a pressure of 1 bar. Okay, so my students, always remember that in any graph, to plot or to particular get a point, you need two information. So for initial point, we have 30 bar and 350 degrees Celsius temperature. And when it says to a pressure of 1 bar, that means it is the next point. The next point, the B point, if we consider the initial point A and the final condition B, on the final point B, then the A point, it has 30 bar and 350 degrees Celsius temperature. So these are the two information. For second point B, we have already 1 bar, but we need one more information, my student, to get that particular point. So to get one more information, is there anything given in this question? Yes, it is given that when it is expanded isentropically. Isentropic means, I discussed probably 2 classes ago, Isentropic. Isen means no change. Entropically means entropy. So no change of entropy. Okay. So isentropic means whatever the entropy of point A, it will remain the same of entropy point B, because that means there will be no change of entropy. So the point A is A, that means entropy of A point will be equal to entropy of the B point. So it is also true. So this is the second information we need for the B point. After getting this information, we'll go to directly to the chart to find out this particular 2 point, and then we will see that our what our question asks, then we'll solve that. But first of all, we need to put these 2 points on our Mollier chart. So if I go to the chart, let me go to a blank chart. Okay, let me go here. So the first thing is that, my student, it is told that the 30 bar and 350 degrees Celsius temperature. You see that this is the 350 degrees Celsius temperature line, this line. If I draw a line of this 350 degrees Celsius, sorry for my bad drawing, and 30 bar, you see that this is the 20 bar, this is the 50 bar line. So what will be the 30 bar? Remember, there is, this graph is not linear. You see that 1, then 2, then again 4, there is no 3, so that's why it is not a linear graph. So you see that this is 20 and this is 50. So in between there are 1, 2 and 3 steps. So there are 3 steps and difference is 50 minus 20, that is 30. 50 minus 20, that is 30. So every step is 10. My student, every step is 10 here in this case. So basically at that time, as the every step is 10, so if it is 20, the next one will be 30. So if I draw a line of 30, whatever the cross section point I will get, that is the point A. So that's how you need to plot, or you need to point out a particular point of the given information in Mollier chart using the two information of A and B. So we use 30 bar and we use 350 degrees Celsius. These are two lines which intersects the line point, that is our desired point A. So let me remove. So this is the point A. And what is the point B? Point B, we have two information. One is pressure 1 bar. So you can see this is the 1 bar pressure line. So this is the 1 bar pressure line. We draw a line. This is the 1 bar pressure line. Okay. So what will be our second point? Interestingly, my student, the other information that is given here, that is isentropically, that means no change of entropy. Okay. So what is the entropy of A point? This is the entropy excess. So the A point entropy will be, if I need to draw a perpendicular line, this will be the A point entropy. This is the, whatever the value, leave it, but this is the A point entropy. And it is told that the B point entropy will be the same of A point entropy, same. So if the B and A point entropy are same, the B point will definitely in this perpendicular line, definitely will be in this perpendicular line. Otherwise, if suppose the B point is here, at that time the entropy value will be bigger, will not be the same. Suppose if it is here, at that time entropy will be the lesser. So it is not the same. To be same, SA equals to SB, to be same, the B point should and must be on this perpendicular line of A entropy line, definitely. So in this line there will be B point. Okay, so where will be the B point? We have the 1 bar information. So 1 bar and this perpendicular line intersects which point? That is the perpendicular B line. So we got A point here and we got a B point here. So that's how we find out the A point and B point. Let me draw one more time. This is A point, this is B point. And our question was two things. One is find out the enthalpy drop. Find out the enthalpy drop. And second one is find out the final condition of the steam. My student, final condition of the steam. This is the A point, that is the initial point. The B point is the final point. So we need to find out that where is the B point. You see that this red line is the dry steam line. This red line is the dry steam line. So I already told that above this red line, that is superheated steam zone, and below the red line, that is wet steam zone. So now when the A comes to B, the superheated steam becomes now wet steam. So the final condition of the steam is wet steam, because now the final point is B. So it has come below the dry steam line. So the initial situation was superheated steam and the final situation is wet steam. That is the final condition of the steam. And one more thing we need to mention, for when you mention wet steam, you also need to mention that what is the dryness fraction of that wet steam. Okay, so you can easily see that this is the dryness fraction line. So if you just draw that line, you see that this is the exact 0.9. So the dryness fraction is 0.9. Suppose if this point was in the middle here, at that time we need to draw the perpendicular line something like this. So it will be middle of 0.85 and 0.9. So it will be 0.87. Suppose the point is here. At that time, what will be the dryness fraction? You just draw the line perpendicular parallel to that line. So it will be 0.95. Similarly, point here, it will be 0.82 or 825. If it is exactly here, it will be 0.8. So you need to find out according to this whether what is the wet steam dryness fraction. So the final condition of the system is wet steam, and also the dryness fraction is 0.9. What was the first thing? The first thing is to find out the enthalpy drop. Enthalpy drop means whatever the enthalpy in the point A, enthalpy means heat, total heat of the system. Whatever the enthalpy of the point A and whatever the enthalpy of the point B and the difference. So if we just draw the two perpendicular line here, because this is the enthalpy scale, and here, and to find out these two value, just subtract the two value, we get the enthalpy drop. It will be, it is 3000. So it will be something like that, 3100, and it is probably if you see that this is 2500. So this is 2400, because you know every step is 100. So this is probably 2450 or 2440, something like that. So if you subtract these two values, we get the enthalpy drop. You see that from this Mollier chart, we get this two information that that HA, that means enthalpy of the first point is 3110, and the second point is 2450. If we subtract that, 660 is the kilojoule per kg is the enthalpy drop, and the B point is located in the wet steam, and also the dryness fraction is x equals to 0.9. So the final condition of the steam is wet steam. So that's how we need to solve this kind of mathematics using Mollier chart. Now I am unmuting my students. If is there any question regarding this type of mathematics? My student, is there any question?
No, sir.
Is there any question?
No,
But how,
sir.
is it clear that Mollier chart is
Yes,
clear?
sir.
Okay. If it is clear, then I will start the next one. And Okay. Okay. You read this that first of all, it is given here the sample of steam at 200 degrees Celsius and a pressure of 7 bar. That means a steam with its initial value is 200 degrees Celsius and the pressure is 7 bar. Okay, so this is the initial point. Is first expanded at a constant enthalpy to 3 bar, then at a constant entropy 0.5 bar. That means 3 point. If you see properly, the initial point is 200 degrees Celsius and 7 bar. Then first expanded it and it becomes 3 bar and the constant enthalpy. That means the enthalpy becomes constant. That means enthalpy of A and enthalpy of B are same. Then at a constant entropy of 0.5 bar. So the pressure is 0.5 bar and the entropy is constant. That means B. Whatever the entropy in the point B, it is same as the point C. So that every point has two information. So using this Mollier chart, you need to find out the enthalpy entropy changes during this process. This process means from A to B and B to C. We need to find out that how much entropy is dropped, how much enthalpy is dropped. Okay, before doing that, we need to plot this 3 point in our Mollier chart. The first point is already given here is 7 bar 200 degrees Celsius. 7 bar 200 degrees Celsius. The second point is 3 bar HA. HA means whatever the enthalpy of point A, it is exact enthalpy of point B because that is known as constant enthalpy. It is given here. And point C, it is 0.5 bar SB. SB means entropy of point B. That means the same entropy of the point B because it is a constant entropy. That means entropy is same both for B and C value, both for B and C point. So whatever the entropy will be point B, it will be exact point C. So that's why HB equals to SB equals to SC. So we try to find out these 3 points in our in a Mollier chart. Let's see that we need to put these 3 points in a Mollier chart. You see that at the first point, that is A, the information is pressure equals to 7 bar and the temperature is 200 degree Celsius. The pressure is 7 bar and the temperature is 200 degree Celsius. So the first point is A, that is 7 bar 200 degrees Celsius. Okay, so if this is the 200 degrees Celsius line, if I draw a line, this is 200 degrees Celsius. Okay, my student. And what will be the 7 bar? This is 4 bar and this is 10 bar. This is 4 bar, this is 10 bar. So in between there are 3, 1, 2, 3 and 4 to 10 to 4. That means every space or every area is for 2. So that means if this is 4, this will be 6, this will be 8. So the 7 will be in between. Let me clear everything. This is 4, the next one will be 6, the next one will be 8, the next one will be 10. So 7 will be the middle of the middle space. So if I draw a middle line of this middle, and if I draw the 200 degrees Celsius, the intersection point is basically a point. I am sorry because of the, you know, what can I say, because of the thickness of this drawing, but intersection point will be the point A. Then our information is the 3 bar and constant enthalpy. So 3 bar, what is that 3 bar? This is 2, this is 4, this is 2, this is 4. So in between it will be 3. So if I draw a line of 3 bar, suppose this is 3 bar, and the constant enthalpy, that means the point of enthalpy are same. So suppose if this is the A point enthalpy, so the B will be exactly the perpendicular line of this point, because both the enthalpy are same. So this perpendicular line will intersect this point, 3 bar point, 3 bar line, and we get the point B. One more time, this is the A point. So the perpendicular line from A to B, which will intersect the 3 bar line, we get the point B. Third one, the C point, the pressure is 0.5 bar. So this is 0.5 bar, and the entropy is constant. That means B point entropy and C point entropy are same. So we will draw a perpendicular line to from B to this 0.5 bar, and the intersection point will be the C point. Okay, so that's how, when it is constant enthalpy, you need to draw the perpendicular line vertically. When it is constant entropy, sorry, I said it, you know, alter. When it is constant enthalpy, you need to draw the perpendicular line horizontally. When it is entropy, constant entropy, you need to draw the perpendicular line vertically. So from this, we get the A, B, and C point, from A, B, and C point. And from this here, the final point is C, isn't it? The final point is C. So we can see from here on that the C point is below the dry steam line. So the final condition of the steam is wet steam. And what is the dryness fraction? The dryness fraction, if I draw the line, the dryness fraction will be 0.95. So this is the final condition of the steam, of the steam. But in our question, it is told that how much energy, how much entropy and enthalpy has been dropped from the process. So the process is two process. One is A to B. One is A to B. And the second process is B to C. One is A to B. The second process is B to C. Okay. So in this two process, we need to find out the enthalpy and entropy drop. So for that, we need to find out all the value of entropy and enthalpy of this 3 point. For A, if I go here, this will be the value of enthalpy A, which will be, this is, if this is 205,000, this will be 2,600, 2,700, 2,800, that will be might be 2,850. Similarly, we need to find out the entropy value from here, which will be probably 6.8. Similarly, we need to find out the enthalpy of B point, enthalpy of C point. Similarly, enthalpy of C point and entropy of C point. So in this way, we need to find out all 6 values of this A, B, and C point from this graph. You see that here it is given here that from the plotting these 3 points on this Mollier chart, we get this 6 value. Okay, from this chart easily we can get this 6 value after finishing the plotting those 3 points. So after that, we need to find out the process A to B. In A to B process, we need to find out the enthalpy drop. So that means A point enthalpy minus B point enthalpy, that is 0 there, because these are constant enthalpy process. And del A, that means entropy drop. So B to A, that means 0.4. Similarly, from B to C, process HB minus HC, we get it, and from for entropy drop HB minus SC, so that is also 0. Here you can see that not SA minus SB, not SA minus SB. In terms of SA minus SB, it is SB minus SA, because of we need to avoid the minus sign. Just we need to avoid the minus sign because SB is greater than. So that's why to find out the difference, we subtract from the bigger one to the smaller one. So in this way, we can easily find out the enthalpy and entropy drop in these two process. So that's how we need to use the Mollier chart. Now I am unmuting all my students. Is there any questions regarding our mathematics? My student, is there any questions? Everyone is unmuted. Is there any question?
No, sir.
Anyone else?
No, sir.
Shakur?
No question, sir. No question, sir.
Yes, try to practice this chart by hand. Okay.
Okay, sir. We will practice.
Is there any questions, Omar, Hafiz,
No, sir. Sir, I have no question. We will practice at home. Then
Hassan,
No, sir, sir.
Yasin?
also Ibrahim here.
No, sir. No, sir.
Ibrahim is here.
Yeah.
Okay. Please, everybody, give your role in the chat box. Ashik,
I think he can.
he got. Everybody, give your role in the chat box.
Okay, sir.
I'm giving Ashik role 02. So basically 14, 21, roll 8, roll
20.
2, roll 24, roll 7, roll 20. So Hamza is absent and Said is absent. These two are absent.
Yeah, absolutely.
Yes, sir.
13. Ali is here. Okay. So 9 students are present. Is there any question available, my student? Is there any question, my student?
Sir, can you repeat when you calculate B to C?
Yes. When I that means calculate means the plotting, the point.
Yes. But
Yes.
plotting B to C.
Plotting B to C. Okay. So from B to C, my student, the information was the pressure becomes 0.5 bar. Okay. So this is the 0.5 bar line. You see that?
Yes.
This is the 0.5 bar line. Just draw the 0.5 bar line. And one more information was given, that is the entropy of B point is B and entropy of C point are equal, the constant entropy. So what is the value of entropy B? So we need to draw the perpendicular line of B to find it out. Suppose this is the value of 0.7, 0.23, something like that. But interestingly, the C point entropy should be same. So the C point should be in this perpendicular line. Otherwise, if the C point is here, suppose if the C point is here, I might use one more color to suppose if the C point is here in this line, at that time the entropy will be something like that, which will be 7.6. Is it same? No. If C point is in this line, then at that time it will be 7. Is it same? No. So
sir.
to exactly be
That's
same, you need to be in the perpendicular line of this B. So that's why the perpendicular line of this and this 0.5 bar, the intersection point is possibly C. I think you get it.
Yes, sir. Thank you.
Okay. Is there any question, my student? My students, is there any question?
No, sir.
No, sir.
Yes, tell, sir. Okay, if there is no question, then I will stop this sharing here. And as you have already given your role, you can, no problem, you can leave, no problem.
Okay, sir.
Okay. So let me stop the recording.